Hello friend, welcome. So after our view model provides pset service, let's go to the view to see how we can generate a user interaction here. And so we want something happen, right? We want something to happen when we click each row, right? Ideally we can get the 0 when we click here, 1 here, 2 here, right? And so let's find out the V stack here. So what about this? On tab, gesture code print. Let's see if we can print out that right when we tap or click this part, right? This V stack. Excuse me. Okay, now let's try it, run it. Here, no. So the problem is it's empty here, and we need to put something like content shape. We can use a rectangle content shape, so it means this rectangle now is clickable. Okay, run it. Let's see. Oh, it works, right? Now let's see if we can collect the column number here. So say, because we have a column here, let's see if we can get that out. Run it. 0, 1, 2, 3, 4, 5, 6. Perfect. So now we can ask a service like this one, our view model, right, to drop a piece at, right? Drop at like column, something like that. But we don't have that yet, right? Let's go back to here to implement that. So function drop at column, like that, and of course we'll dedicate this job to our model, right? And let's create one here in the model. Piece at, okay, put it here. Drop at column int. So this is our external label, this is internal label. Drop at. So let's create a piece. Pieces box dot insert a new piece, right? So column is this column. Let's just put it on the bottom this time. Player yellow, red will go first. Okay, so red. Now let's use the so by default, right, all the function inside the struct is immutable. So now we need to report to the platform iOS system. This one is modifying the state of our object. Yeah. Now we can remove that because we should be able to drop our piece manually. Okay, now we have that service, we can delegate this job to our command B. Drop. No. Dot. Yeah, drop at column. This makes sense. Okay, so let's see. Now go back to the view to call this drop at. Okay, because we set this to be observed object, right? So whenever we modify the something on the model through the view model, what? Command B. Yeah, it compiles. So when we interact on the view, right, we call this function, and then we modified this thing, this model, because this one is published. It means there's a publisher behind the scene of our view model. It will send out, broadcast the change here, and this guy, the view is the observer. It will observe this observed object, this guy. So when the observer, our view, get notified, right? Something changed. It means it received the published message. Then it will repaint the whole view. Actually, the body here will be re-rendered. Okay, let's see. Run it. And drop. Yes, it works. You see? Cool, right? Now that's at whose turn here. Okay, so private whose turn at the beginning, player is red's turn. Now after we drop the piece, we'll toggle whose turn, right? So whose turn equals if whose turn is red, then it will be yellow, otherwise it will be red. Okay, dot red. So now we can toggle the whose turn. Run it. Red, yellow. Oh, whose turn is red? Let's go to the view here. Fill in. If it's red, we'll change it to yellow, otherwise it will be red. Oh, sorry about that. This one we haven't changed this to whose turn. Yeah. Now red, yellow, red, yellow, red, yellow, red. Ta-da! To finish drop piece add, right, we need we'd better to create a helper function like number of pieces at column. Okay, like that. Return, of course, int, right? So we'll have a count here, so count equals 0 and returned count, and we'll look through all the pieces in our pieces box and to see if if the pieces column, right, is same as the specified column, then we can add 1 to our count, right? So or we can use a filter, pieces box dot filter. The condition is the pieces dot no, the code should be here. This is the iterator dot column equals our column. So this one dot count. We can simply okay, so we don't need this. It seems to us that is the number of pieces at that, so we don't need this, right? Because the language is so powerful, we can just get that, right? Number of pieces at column equals that. Then we can put this one here and let's test it. So this means $0 is this guy for piece in, right? Let's give a try. Red, yellow, red, right? It works. So cool. So that's explain the okay. Now we can clean up. Let's put it back. So this logic is same. But using the filter is so cool, right? So this one, I think, if it's hard to understand, I explain in this way. Okay, so this guy is the input here, piece in the separator. So we'll comment out this one. So it's actually piece dot column dot because this one we can use if there another one, right? If there's another one, like, then the second one can be represented using $1. But this filter, this filter function only accept one. No, this filter accept a function. That function has only one parameter in this guy. Okay, so yeah, let's try it. It's the same, right? Yeah, and let's clean up now. So, or yeah, if we can, let's double check if the logic is the same as that, right? Let number of pieces at that equals our number of pieces at let's try it. The result should be the same, right? Cool. So there are so many different ways to write the code, right? So let's use the shortest, the cool one. Okay, so let's clean up now, and let's clean up all of them here. Oh, not yet. So it's like that. Because it's so simple, a single line, so we can just use, we don't need to return keywords. So this one, dot colon equals colon. Can we just use colon here? No, it doesn't make sense. Yeah, so that's number pieces of colon. What? Command B. Cannot value. Oh, I forgot this dot count. Yeah. This guy return, right? Subset with this condition, right? So we'll count all of them. So cool. Run it. Before we commit, right, we want to make sure everything still works as expected. Okay, great. That's it. Thank you for watching. See you next time.